Hello everyone, we're from Group 8 and today we will be presenting the results of our end-to-end data science project regarding streaming application viewership behavior using the CRISP-DM methodology. This project will be discussed sequentially starting from data understanding all the way to final model evaluation. Okay. Um, Before that, we would like to introduce ourselves. My name is Adela Shaina, and these are my teammates, Danendra Arisputra and Arafa Hilmi Hadian and Faiz Rifat Ronazi. So for the next one is about the data understanding, or as we say, is the dataset profile, where the key points is data sourced from Kaggle, which is a streaming viewership dataset, and the dimension is 6,214 rows. And the target variable is duration underscore watch per minute. And then feature include genre, age, gender, subscription status, and device type, and interaction event. In the data understanding phase, the dataset we utilize consists of 6,214 rows and 16 columns or features. The core focus or target variable of our modeling is duration and watch in minutes, where our objective is to predict how long a user will stream content based on a combination of demographic features. Okay, for the next one is the data understanding for the data quality report, where before moving on to data cleaning, we conducted a comprehensive data quality audit. Fortunately, there were zero missing values and no duplicate rows found in the data set. Through descriptive statistical analysis, we observed that the skewness for numeric features like age, ratings, and interaction events all fell within a stable range of 0.5. This indicates that their distributions are relatively symmetrical or near normal. However, the IQR method still flagged several extreme values on the tails of the distribution that need to be addressed to ensure the stability of our linear models later on. For the next one will be explained by Arafa.
Yes, so entering the data preparation phase, our first step was to ensure data integrity through data cleaning. We performed text standardization on categorical features to remove unnecessary leading or trailing whitescapes. Regarding the outliers mentioned by Adela, we can choose IQR capping or clipping strategy rather than deleting them. This means any value lying outside the reasonable boundaries were kept at their at their res- at their respective IQR maximum or minimum thresholds. This strategy is crucial because it allows us to clean the noise without losing a single row of data, keeping our dataset size completely intact at 6,214 rows. And then to enrich our analysis, we perform feature engineering by constructing three new derived attributes. First is engagement score, which normalizes the relationship between watch duration and interaction into a 0 to 1 scale. Second is age group, which segments users to six distinct age brackets. And third, a binary flag called high engagement, which successfully captured 1,243 high engagement sessions. From our post-cleaning EDA, we found an interesting insight. The correlation matrix reveals that relationships between numeric variables are generally weak, sitting below 0.3. Furthermore, viewing behavior between free and premium accounts heavily overlaps, indicating that subscription status is not yet a strong differentiator of user behavior in this dataset. And then the final step in data preparation was transforming the data to make it ready for machine learning algorithms. We apply label encoding for ordinal variable and one-hot encoding for nominal variables. Expanding our feature matrix dimension to 23 ready-to-use features, the data was then split into a 80-20 ratio, resulting in 4,971 rows for training and 1,243 rows for testing. Finally, all numeric features were standardized using a standard scalar to achieve a mean of 0 and variance of 1, preventing any scaling bias. And then the modeling phase will now be explained by Vice Rifat.
Okay, so we now enter the modeling phase. Before training complex algorithms, we tested whether the relationship between the features and watch duration was nonlinear using polynomial regression. We tuned the polynomial degree using five-fold cross-validation, and the results were clear. At degree 1, the CVRMSE stood at 3,476. However, when raised to degree 2 and 3, the error expanded to 41.14, and this proved that increasing the polynomial degree only triggers overfitting without adding any predictive value. Therefore, we maintain a baseline linear relationship for our models. And next, we train four algorithms simultaneously using their default parameter as comparative baseline. Evaluation result on the test data show that linear regression led the pack with the lowest RMSE of 34.40 minutes, followed closely by random forest at 35.01 minutes. On the other hand, distance-based model like KNN and boosting models like the default XGBoost actually yielded higher errors at 37.41 and 37.57 minutes, respectively. This initially outcome indicated that our data structure heavily required aggressive parameter optimizations. Thank you.
So for the next is me to explain the hyperparameter tuning with grid search CV plus 5-fold CV. So in the KNN regressor, we have the best CVRMSE with 35.9 minutes, and so on and so on for each machine learning method that we use. And at the feature selection, we use first method is the filtering mutual information, and the selected features outcomes with 23 features, KNN filtering features with 35.02 minutes. Second is embedded features. And embedded features is evaluate the important features while machine learning processing. And random forest result is random forest result that the highest score based on this feature. We can see there our embedded method on the diagram. The third one is the wrapper, which wrapper method evaluate the subset feature based on performance in each model's actual. With RFE, they delete the feature with the smallest weight until we get the target variable. And with this, we can see that the device type smartphone have the least important, while the rest of is 1, 2, 3, 4, 5. The rest of them, which from playback and until the languages user use, is the important thing in this project. And feature selection third is our feature selections RMSE comparison. Based on all methods in this feature, we have the feature selection RSME comparison table diagram, which show us all features, filtering, embedded, and wrapper. And we compared the RMSE and the and features. And the final model evaluation here, all models we evaluate with 3 standard metrics: regression, RMSE, MAE, and R square. And the best model we can see that after we tune the precision of the machine learning is the XGBoost with highest RMSE and MAE and the R square. The last one is this our final comparison with those 5 machine learning models. And to evaluate our diagnostic, we predict the actual versus predicted plot, and this is our result. Our interpretation is mean residual in -1.3, standard residual of people watch the movie 34 minutes, residual skew on 0.01, which ideally 0 is unbiased. And this residual versus fitted plot that we use in here. And the final interpretation with IDA findings for numerical fiber have distributed relatively very symmetric after IQR capping that we implement there. And there is no significant difference between free or premium at the features indicate that type of subscription. There's no differentiator in this project, and correlation between every numerical variable very weak here, and it's describe us about the characteristic synthetic dataset. There's feature not to have a good relationship between them. And we have interpretation on the feature selection findings and model performance. Thank you for listening us, and thank you.